If you're running workloads across multiple clouds, you already know the incredible power it gives you. But you also know the financial risk that comes with it. Today, we're going to roll up our sleeves and actually architect a solution to one of the biggest headaches in FinOps, catching those shocking, unexpected costs before they turn into a full-blown crisis. $50,000. And nope, that is not a hypothetical number. That's the kind of bill you could be staring at from just one single unnoticed rogue workload that a developer accidentally left running over a long weekend, a simple mistake with a jaw-dropping 5-figure price tag. So let me ask you straight up, how would your current system even catch something like that? Would you even have a clue it was happening before that massive bill lands on your desk weeks later? That's the exact terrifying problem we're going to solve right now. Let's dive in. So here's the game plan. We'll start by looking at the problem itself, what I call the multi-cloud cost nightmare. Then we'll build our solution, our anomaly detection blueprint, piece by piece. We'll cover how to establish baselines, then how to define thresholds, and finally, how to activate alerts that actually work. And to wrap it all up, we'll see our system in action, catching that exact rogue workload we just talked about. First things first, let's meet the villain of our story, the rogue workload. Now, this isn't some shadowy hacker. Nah, it's usually just an accident. You know, a developer spins up a super high-powered script for a quick test and then just forgets to turn it off. Or maybe a misconfigured auto-scaling group goes wild and spins up hundreds of instances for no reason. It is deceptively easy for this to happen. And that's really where the trouble starts. In a single cloud, it's already hard enough to keep track of costs. But when you go multi-cloud, you're juggling completely different billing models, different services, different APIs. The complexity just explodes. So a single error doesn't just add a little cost. It cascades, creating this financial black hole before your finance team even gets the monthly invoice. Okay, so how do we fight back? Well, it's not about buying one magic tool. It's about architecture. We need a systematic approach to build real financial control. And the one we're building today is based on 3 core pillars. These are the 3 pillars of our whole system. It's pretty straightforward. First, we figure out what normal looks like by establishing baselines. Second, we decide what abnormal is by defining thresholds. And third, we make sure we actually do something about it by activating smart alerts. It sounds simple, but in practice, it is incredibly powerful. All right, pillar 1, establishing baselines. This is the absolute foundation of everything else we're going to do. You simply cannot spot something weird if you don't have a crystal clear, data-driven picture of your normal day-to-day cloud spend. Now, a baseline isn't just your average daily spend. No, it's way smarter than that. A real baseline is a sophisticated model, usually powered by machine learning, that actually understands your business. It knows your spend is different on a Tuesday than on a Saturday. It expects that big processing job you run at the end of every quarter. It creates a living, breathing picture of what your costs should look like. Now, for all you architects watching, this is where the real fun begins. The core technical challenge here is that to build one unified baseline, you have to pull in and normalize data from completely different places. The AWS Cost Explorer API, for instance, is super detailed, but man, filtering it correctly is a steep learning curve. Then you've got Azure's API, which uses a totally different data structure, and GCP makes you link everything to specific projects. So your first real job is to build a data pipeline that can take these 3 totally different streams and turn them into one single source of truth. Okay, so once we have our baseline, our model of what's normal, we can move on to pillar 2, defining thresholds. This is where we get to draw a line in the sand and tell our system, hey, if costs ever cross this line, that's a problem, and I need to know about it. Just look at this. On the left, you see your normal daily spend, just humming along at its expected level. On the right, bam, that's our rogue workload. That's an 800% spike. This isn't some tiny change, it's a massive, catastrophic deviation. A threshold is designed to catch exactly this kind of jump instantly. And here's the official definition. A threshold is just that predefined rule. It could be something simple like, alert me if the daily spend is 50% above the baseline. Or you could get more specific like, alert me if the cost for Project Phoenix goes $1,000 over its baseline. It's the simple trigger that connects our detection model to an actual action. And that brings us to our final pillar, activating alerts. Because let's be real, detecting a problem is totally useless if nobody knows about it, or if the notification just gets buried in a sea of low-priority emails. This step is all about making the data actionable, fast. A good alert is not a generic warning, costs are high message. That's just noise. An effective alert has to be actionable. It tells you exactly what you need to know, which service in which region just spiked, how much did it go up by, and crucially, who's responsible for it. This is where having a great tagging strategy is absolutely critical. And of course, it should have a direct link to a dashboard so you can start investigating immediately. The whole point is to shrink the time from detection to resolution. All right, we've built the whole architecture. We've got our baselines, we've got our thresholds, and we've got our smart alerts all set up. So now let's rewind the clock and see exactly how our new system handles that $50,000 weekend nightmare that we started with. Now this is where it all comes together. Check this out. At 10 p.m. on a Friday, the bad workload gets deployed. Our system, which is always watching, sees that cost spike and crosses our threshold just 15 minutes later. 1 minute after that, a rich, detailed alert hits the on-call engineer's Slack channel, and by 10:20 p.m., just 20 minutes after the mistake was even made, the engineer has already terminated the workload. A potential $50,000 disaster has just been squashed into a minor double-digit expense. That is a huge win. And that right there is the ultimate takeaway. This is about so much more than just saving money. It's about fundamentally changing how you operate. You go from this state of reactive panic, where you're finding out about huge problems weeks too late, to a state of proactive, automated, and intelligent oversight. You're no longer flying blind in the cloud. I want to leave you with this final thought. Try not to think of cost spikes as just a financial problem. An anomaly is a signal. It's a story that your data is trying to tell you. A story about a misconfiguration or a bug, or maybe a broken process somewhere. The system we've just architected isn't just a cost-saving tool. It's a system to help you learn how to listen to those stories. So start listening.